Look up at the night sky and lose yourself in the twinkling light of billions of stars. Have you ever wondered, where did this vast universe come from? Will it last forever, like a timeless love song of time and space? Or is it all just a fleeting dream, a brief illusion in the endless flow of existence? We, tiny beings on a pale blue dot, yearn to understand the universe's origin and its ultimate fate. It's a burning desire, pushing us beyond the limits of our knowledge to unveil the secrets of the cosmos. Will this vast universe, with all its beauty and grandeur, one day face its end? A cold, silent end, where everything fades into eternal darkness. What if the universe really does have an expiration date? A day when all light, all life, and even time itself ceases to exist. For decades, scientists have dedicated their lives to searching for answers about the universe's destiny. They've built giant telescopes, launched probes into the deepest reaches of space, and developed complex theories to decode the universe's mysteries. But are we, the inheritors of human knowledge, ready to face the truth about the universe's ultimate fate? Our journey of cosmic discovery begins with a singularity, an initial explosion called the Big Bang. That moment, roughly 13.8 billion years ago, marked the birth of time, space, and everything we know today. Imagine, from an incredibly tiny point containing all the energy and matter of the universe, a tremendous explosion occurred, giving birth to the cosmos. An explosion of unimaginable power, ripping apart space and time, creating a universe that continues to expand to this day. But how did the universe expand from a singularity to the vast expanse we see today? It's a question that has puzzled generations of scientists. They've studied the cosmic microwave background radiation, the remnants of the Big Bang, to learn about the universe's first moments. They've analyzed the chemical composition of stars and galaxies to reconstruct the universe's evolution over billions of years. Can we ever fully understand this origin? Can we decode all the secrets of the Big Bang, the event that birthed everything? It remains a big question, challenging human intellect. From the first elementary particles formed after the Big Bang to the appearance of atoms, stars, and galaxies, the universe has undergone a complex and wondrous evolutionary process. Billions of years passed, the universe continued to expand and cool, creating conditions for life to emerge and flourish on at least one planet we know, Earth. And we, the fortunate beings living in this universe, continue our journey of discovery, seeking to understand our own origins and destiny. The universe isn't just existing, it's constantly expanding. Like a balloon being inflated, the universe is getting bigger and bigger at an ever-increasing rate. But why is the universe expanding? It's one of the biggest mysteries in modern cosmology. Scientists have proposed the existence of a mysterious form of energy called dark energy, which makes up most of the universe's energy and drives this expansion. What is dark energy? We know almost nothing about it. It's invisible, doesn't interact with ordinary matter, and reveals itself only through its effect on the universe's expansion. Does dark energy really exist? And is it the key to unlocking the mystery of the universe's expansion? What if this expansion rate spirals out of control? Some scientists worry that if dark energy continues to increase, it could lead to a scenario called the Big Rip, where the universe is torn apart. A terrifying prospect, isn't it? But is this the universe's ultimate fate? We don't have the answer yet. The journey of cosmic discovery continues, and we're still searching for answers to the universe's biggest mysteries. Heat death, a concept that sounds abstract but carries a terrifying weight, is the predicted ultimate state of the universe, where everything descends into absolute stillness. Imagine a universe devoid of life, light, and any motion whatsoever, a universe that has reached a state of maximum thermodynamic equilibrium. That is heat death. In this state, all energy is evenly distributed throughout the universe, leaving no energy differences to perform work, sustain life, or even generate light. Everything becomes still, cold, and inert. The foundation of heat death lies in the second law of thermodynamics, an unforgiving law governing all processes in the universe. This law states that entropy, a measure of disorder, always tends to increase in a closed system. The universe, if considered a closed system, cannot escape this law. Entropy will continue to increase until it reaches its maximum, at which point the universe will fall into a state of thermodynamic equilibrium, heat death. What happens when the temperature reaches absolute zero? Theoretically, at this temperature, all particle motion ceases. No vibrations, no energy, only absolute stillness remains. Is this the final state of the universe? A haunting question that forces us to ponder the very nature of existence. Although heat death is predicted to occur in the very distant future, perhaps trillions or even quadrillions of years from now, we can already see faint hints of it in the universe today. No new stars. Star formation is a vital process in the universe, creating energy and heavy elements. However, the supply of gas and dust, the raw materials for star formation, is gradually depleting. Will there come a time when the universe no longer has enough material to create new stars? The universe would then gradually become darker and colder. Why is the supply of gas and dust dwindling? Is it a sign that the universe is slowly inching towards heat death? Old stars dying. Stars, no matter how brightly they shine, have finite lifespans. When a star burns through its nuclear fuel, it dies, leaving behind a white dwarf, a neutron star, or a black hole. The death of a star isn't just the end of a celestial body, it's also the loss of a vital energy source in the universe. Will the death of billions of stars push the universe closer to heat death? Approaching absolute zero. The universe is expanding, and as it does, its temperature gradually decreases. Will the universe's temperature eventually reach absolute zero? When all motion stops, will everything truly end? A universe frozen in eternal silence is a terrifying prospect. But is it reality? Imagine a dark, cold universe, devoid of life, light, and any activity. This is the ultimate vision of heat death, a desolate universe where everything is frozen in eternal silence. Will anything exist after this death? Will there be some kind of rebirth, or is it simply the absolute end? A big question beyond our current understanding. We can only speculate, imagine, and await answers from future scientific discoveries. But whatever the outcome, heat death remains a stark reminder of the finite nature of existence, the fragility of life, and the importance of cherishing each moment we have. Heat death, a cold and silent vision, isn't the only theory about the universe's end. Scientists have proposed various scenarios, each painting a different picture of everything's ultimate fate. These scenarios, though differing in details, share a common thread. They raise profound questions about the nature of the universe, our existence, and the meaning of it all. If the Big Bang was the beginning, the Big Crunch could be considered the end. In this scenario, instead of expanding forever, the universe will begin to contract under the influence of gravity. Imagine galaxies drawing closer together, colliding and merging, space shrinking, and temperatures rising. A complete reversal of the current expansion. What happens when all galaxies, planets, and light are drawn into a single point? Will the universe return to its initial state, an infinitely small and hot singularity? And from that singularity, will a new Big Bang erupt, starting a new cycle of the universe? What if the Big Crunch leads to a new Big Bang? Would this be an eternal loop, where the universe is continuously born and destroyed? A captivating idea, isn't it? If dark energy continues to increase at its current rate, or even accelerates, it could lead to a scenario called the Big Rip. In this scenario, the universe's expansion spirals out of control, tearing apart everything in its path. Galaxies would be ripped apart, stars would be ripped apart, planets would be ripped apart, and even atoms themselves would be ripped apart. As dark energy dominates, will the universe be torn to shreds? Imagine a force so powerful that it can break every bond, every structure, from the largest to the smallest. What remains after a universe torn into its fundamental particles? Is this the absolute end, or simply a transition to another state beyond our comprehension? Vacuum decay, a lesser-known but equally terrifying scenario, involves the universe's energy state. According to quantum field theory, the universe can exist in different energy states, like a ball resting at different points on a hill. Our current universe is thought to be in a stable energy state, but is it the lowest possible energy state? A sudden quantum event, could the universe abruptly vanish? If a lower energy state exists, the universe could suddenly collapse into that state, like a ball rolling from the top of a hill to the bottom. If a lower energy state emerges, what happens to all of space and time? Will the universe vanish in an instant, leaving no trace? An unbelievable scenario, but not entirely impossible. These theories, though seemingly fantastical, are based on modern scientific understanding. They reveal the universe's diversity and complexity, while reminding us that our knowledge of the cosmos remains limited. Which scenario will become reality? The answer lies in the future. The universe has existed for 13.8 billion years, an unimaginable length of time compared to a human lifespan. In this vast flow of time, where are we? Has the universe reached its final stages, or are there billions of years still ahead? Are we living in the universe's golden age, or just a fleeting moment before darkness falls? Determining our place in the universe's timeline is not just a scientific problem, it's a profound philosophical question. It helps us reassess our place in the vast cosmos, reevaluate the value of existence, and guide humanity's future. What if these predictions are wrong? Are there scenarios we haven't even considered? This uncertainty fuels our search for answers. Faced with these daunting scenarios about the universe's end, what can humanity do? Can we survive until the universe reaches heat death? Can technology or science help us escape this fate? These questions, though seemingly far-fetched, carry deep meaning. Human history is a history of discovery, innovation, and adaptation. We have overcome countless difficulties and challenges to survive and thrive. Can we continue to harness this spirit to face even greater challenges in the future? Can science and technology help us find solutions to prolong life, perhaps even transcend the limits of time and space? It's a monumental challenge, requiring the continuous effort of all humankind. Theories about the multiverse and the cyclic universe offer glimmers of hope for our continued existence. The multiverse, a concept suggesting our universe is just one of countless others, poses the question, could we jump to another universe when our current one ends? Do parallel universes exist where life continues to thrive and prosper? The cyclic universe, a theory proposing that the universe undergoes repeating cycles of big bangs and big crunches, also offers another hope. Is there truly an end, or just a part of an eternal loop? After the big crunch, will a new universe be born, bringing new opportunities for life? These theories, though unproven, open new avenues for scientific inquiry, spark human imagination, and offer hope for a future beyond the limits of our current universe. Can we find answers to these questions? Only time and the relentless pursuit of scientific knowledge can tell. The journey of exploring the universe, from the first naked-eye observations to the most complex theories of modern physics, has given us a deeper understanding of our place in the vast cosmos. But the more we explore, the more we realize our smallness, the finite nature of existence, and the vastness of the unknown. In the face of the immense universe, with its billions of galaxies, each containing billions of stars, we humans are but tiny beings, living on a small planet, orbiting an ordinary star. Are we merely fleeting creatures? Does our existence hold any significance in the grand scheme of the universe? Recognizing our smallness isn't a cause for despair. It's an opportunity to appreciate what we have even more. Life, however brief, is a precious gift. Instead of worrying about the end, we should cherish the present, live each moment to the fullest, and contribute positively to the world around us. Perhaps, instead of fearing the end, we should cherish the present, love each other more deeply, and live meaningful lives. Because ultimately, all we have is now. Thanks for watching the whole video. Don't forget to like and subscribe for more content.